In this video, we are going to do revisions on mole concept. So the mole concept that I'm going to cover in this video are the concepts that you have learned in SPM chemistry. What's the relationship between atomic mass, relative atomic mass, and molar mass? For example, here we have one sodium atom with atomic mass of 23U. For atoms, their masses are quantified in terms of unified atomic mass U because they are very light. So when this one sodium atom is compared with the standard 1/12 the mass of one carbon-12 atom, we get the relative atomic mass of sodium as 23. This means that sodium atom is 23 times heavier compared to the standard. Let's say now we have 6.02 times 10 to the power of 23 sodium atoms, and we weigh the atoms, and the mass that we get will be 23 grams. And we know that 6.02 times 10 to the power of 23 is equivalent to 1 mole. So we can also say that the mass of 1 mole of sodium atoms is 23 grams. The molar mass of sodium atoms is actually 23 grams per mole. From the atomic mass, relative atomic mass, and molar mass of sodium, we can see that all of them having same numerical value, which is 23. So what can we conclude from here? We can conclude that if we want to determine molar mass of a substance, we can actually obtain the molar mass of a substance from its relative atomic mass. What's the relationship between molecular mass, relative molecular mass, and molar mass? For example, here we have one oxygen molecule with molecular mass of 32U. For molecules, their masses are also quantified in terms of unified atomic mass U because they are very light. So when this one oxygen molecule is compared to the standard 1/12 the mass of one carbon-12 atom, we get the relative molecular mass of oxygen as 32. This means that one oxygen molecule is 32 times heavier compared to the standard. Let's say now we have 6.02 times 10 to the power of 23 oxygen molecules, and we weigh the molecules. The mass that we get will be 32 grams. We know that 6.02 times 10 to the power of 23 is equivalent to 1 mole. So we can say that the mass of 1 mole of oxygen molecules is 32 grams, and the molar mass of oxygen molecules is 32 grams per mole. From the molecular mass, relative molecular mass, and molar mass of oxygen, we can see that all of them having same numerical value. Therefore, we can conclude that if we want to determine the molar mass of a substance in terms of molecules, we can get it from its relative molecular mass. What's the relationship between relative atomic mass and relative molecular mass? For example, here, one oxygen atom with atomic mass of 16U having the relative atomic mass of 16. One oxygen molecule with 2 oxygen atoms combined having the relative molecular mass of 32. How do we get the 32? Basically, just by summing up the relative atomic mass of 2 oxygen atoms, 16 plus 16 to give us 32. From this, we can conclude that if we want to get the relative molecular mass of a molecule, we just need to sum out the relative atomic mass of atoms present in the molecule. This concept also applies in determining the relative formula mass for ionic compound. Now we move on to look at how to calculate relative molecular mass or relative formula mass for a compound. Must remember, we need to apply the concept whereby to determine the relative molecular mass or relative formula mass of a compound, we need to sum up the relative atomic mass of atoms present in the molecule or in the compound. We shall look at the first example on how to calculate the relative molecular mass of propanoic acid. Again, to calculate the relative molecular mass, we need to sum up the relative atomic mass of atoms present in the molecule. So in the propanoic acid, it consists of carbon, and from the table, we can see that carbon, the relative atomic mass is 12. So 12, and there are 2 carbon here, so times 2. Sum up with hydrogen, the relative atomic mass is 1. So 1, and there are 5 hydrogen, so times 5, plus another carbon, relative atomic mass is 12. 1 carbon, plus oxygen, relative atomic mass is 16. And there are 2 oxygen, so times 2, plus another hydrogen with relative atomic mass 1. And when we sum out all the relative atomic mass of the atoms present in the molecule, we get 74. And 74 is the relative molecular mass for propanoic acid. Now we move on to look at second example, magnesium phosphate. Magnesium phosphate is an ionic compound, so we are calculating the relative formula mass. So how to calculate the relative formula mass? It's the same thing. We need to sum out the relative atomic masses of all the atoms present in magnesium phosphate. So the first atom present is magnesium with the relative atomic mass of 24.3. And there are 3 magnesium, so times 3. And then plus 2 multiply with the PO4, because this PO4 is inside the 2, therefore the 2 is outside, multiply with the relative atomic mass of phosphorus. So for phosphorus, from the table we can see that the relative atomic mass is 31, and there is only 1 phosphorus, followed by oxygen. So oxygen, the relative atomic mass is 16, and there are 4 oxygens in the magnesium phosphate. So sum this out, then we shall get 262.9 as the relative formula mass for magnesium phosphate. Example 3, we still calculate the relative formula mass of ionic compound, since calcium chloride is an ionic compound, but calcium chloride is hydrated. So how do we calculate the relative formula mass of hydrated ionic compound? So basically it's still applying the same concept. We sum out the relative atomic masses for all the atoms that present in the compound. So the first atom that is present is calcium. From the table we can see that the relative atomic mass is 40.1, and there is 1 calcium plus chlorine. The relative atomic mass is 35.5, and there are 2 chlorine, so times 2. And then, even though there's a dot here, but remember the concept is sum out the relative atomic mass of all the atoms present. So it is still addition. So don't get confused. We still sum them out. So plus, so there are 2 here. There's 2 here. So means that there are 2 water molecules combined to the calcium chloride. So therefore 2 outside with the relative atomic mass of hydrogen and oxygen inside. Followed by hydrogen, the relative atomic mass is 1 from the table, and there are 2 hydrogen times 2 plus oxygen. From the table we can see that the relative atomic mass is 16, and there's 1 oxygen, and if we sum out the whole thing, we shall get the relative formula mass for hydrated calcium chloride as 147.1. In chemistry, number of moles is very important, and usually we compare between 2 substances in terms of number of moles. Therefore, it is very important for you to know the formula that you can use to convert one quantity to number of moles for you to do the comparison. And in high school chemistry, you have learned 4 formula where you can convert one quantities to number of moles. So the first formula is number of moles equals to mass of a substance divided by molar mass. So if you have been given the mass of a substance and you want to find number of moles, you just need to use the mass of the substance divided by the molar mass of the substance. And the second formula to find number of moles is, if you have been given volume of gas, you can divide it with molar volume, and this molar volume depends on the condition. So if you have been given room condition, then the molar volume will be 24 dm³ per mole. So if you want to find the number of moles under room condition, you just need to use the volume of the gas divided by 24 dm³ per mole to get the number of moles of the gas. And if the conditions given is standard temperature and pressure, STP, then you need to divide the volume of gas with the molar volume 22.4 dm³ per mole to get the number of moles of the gas. And if you have been given the number of particles, be it in terms of ions, formula units, molecules, or atoms, you can use the number of particles and then divide it with Avogadro constant, and you know that the Avogadro constant is 6.02 times 10 to the power of 23 particles per mole to give you the number of moles. And number 4 is for solution. If you want to find the number of moles of a solute, basically you just need to multiply the molarity of the solution with the volume of solution in liter to get the number of moles of solute. To do problem solving involving number of moles, basically involve 2 steps or 3 steps, depends on the question. If the question given A and asks for A, then only involve 2 steps. Step number 1, we can calculate the number of moles of A based on whatever information that is being given to us. And in step number 2, we calculate whatever that is being asked using the number of moles of A that we calculated in step 1. So when involved 3 steps, it is when we are being given A and then asked for B. Then it will involve 3 steps in the problem solving. Step number 1, we calculate the number of moles of A first, based on whatever information of A that is being given to us. And then in step number 2, we need to do comparison based on the stoichiometric relationship between A and B. And after that, we will get the number of moles of B from the comparison. Then in step number 3, we only calculate whatever of B that is being asked using the number of moles of B's that we get in step number 2. Now we move on to look at example 1. So in example 1, we are being given volume of carbon dioxide gas at STB. So how do I know that this is volume of gas? It is because of the unit dm cube. So means that this must be volume. And then given in the question, it is gas. So this is volume of carbon dioxide gas at STP that is being given. So we are being given A. And then we are being asked about the mass of carbon dioxide. Again, it's carbon dioxide. So we are being asked for A. So from the question, we know that this must be the 2 steps question because given A, ask for A. So only involve 2 steps. So in step number 1, we need to calculate the number of moles of A, so the number of moles of carbon dioxide based on the information given. So we are being given volume of gas. So to calculate the number of moles means that we need to use the formula number of moles equals to volume of gas divided by molar volume, and the molar volume here is STP, so therefore it's 22.4 dm cube per mole to give us 9.5 times 10 to the power of negative 2 mole. Then in step number 2, we are being asked about mass of carbon dioxide, so we need to use the number of moles in the step 1 to calculate the mass. So in step number 2, we need to use this formula because we have the number of moles and then we want to calculate the mass of carbon dioxide. So how do we calculate the mass of carbon dioxide? So we use the number of mole multiplied by the molar mass. So still remember, how do we get the molar mass of carbon dioxide? We find the molar mass from the relative molecular mass of carbon dioxide. So we will get 44 gram per mole, and then we multiplied it with the number of moles to get the mass of carbon dioxide as 4.18 gram. In example 2, we are being given the mass of glucose, and then we are being asked about number of oxygen atom. So we are being given glucose A, but asked about oxygen, so being asked about B. Therefore, to do the problem solving, it will involve 3 steps. So again, step number 1, we calculate the number of moles based on the information given. So we are being given mass. Therefore, we need to use the formula number of moles equals to mass divided by molar mass to find the number of moles of glucose. And how do we get the molar mass of glucose? Again, from the relative molecular mass of glucose. And by dividing the mass of glucose with the molar mass of glucose, then we get the number of moles of glucose as 7.5 times 10 to the power of negative 3 mole. Then in step number 2, we need to do the stoichiometric comparison between A and B to find the number of moles of B. For this, we can see that inside 1 mole of glucose, there are 6 moles of oxygen. So this is the relationship, the stoichiometric relationship. In 1 mole of glucose, there are 6 moles of oxygen. And now we only having 7.5 times 10 to the power of negative 3 mole of glucose, and this is equivalent to X mole of oxygen. So how do we find this X mole of oxygen? So mathematically, we will do cross multiplying. So cross multiplying, so 7.5 times 10 to the power of negative 3 multiplied by 6 moles of oxygen. We do the cross multiply, and then divide with 1 mole of glucose. Divide with 1 mole of glucose. Cross we multiply and then divide. Cross we multiply and then divide to give us 4.5 times 10 to the power of negative 2 moles of oxygen. So this is the number of moles of B that we get from step number 2. And then to find the number of oxygen atoms, then in step number 3, we need to apply another formula. So we have the number of moles of B already. Now we want to find the number of oxygen atoms. Therefore, we need to use this formula. So this is the number of moles of oxygen multiplied by the Avogadro constant, 6.02 times 10 to the power of 23, to give us 2.709 times 10 to the power of 22 oxygen atoms as the answer. Problem solving involves chemical reaction. Usually it will be 3 steps, because usually will be given A and asked for B. Like for example, in this question, we have been given the information on hydrochloric acid, but being asked about hydrogen gas. So this is given A, asked for B. Therefore, 3 steps is involved in solving this question. So step number 1, based on the information that is being given, we need to calculate the number of moles of A. Since we have been given the molarity and volume of solution, therefore we need to use molarity multiplied by volume of solutions in liter to find the number of moles of solute hydrochloric acid. So by multiplying 2 molar with 10 ml convert to liter, that is equivalent to 0.01 liter, we get the number of moles of hydrochloric acid as 2 times 10 to the power of negative 2 mole. Then in step number 2, we need to write out the stoichiometric relationship between A and B. When involving chemical reaction, the stoichiometric relationship is the stoichiometric coefficient in the balanced chemical equation. So we need to refer to the balanced chemical equation to find their stoichiometric relationship. From the balanced chemical equation, we can see that 2 moles of hydrochloric acid will produce 1 mole of hydrogen gas. So that is the stoichiometric relationship between the 2 substances. 2 mole of hydrochloric acid produce 1 mole of hydrogen gas. And now we only have 2 times 10 to the power of negative 2 moles of hydrochloric acid, and then we are expecting X mole of hydrogen gas being produced. So how do we calculate the X moles of hydrogen gas? Again, mathematically, we do cross, we multiply, and then divide. Therefore, 2 times 10 to the power of negative 2 multiplied by 1 mole of hydrogen gas, divide by 2 moles of hydrochloric acid, and the mole of hydrochloric acid we can cancel out to give us 1 times 10 to the power of negative 2 moles of hydrogen gas being produced. After we get the number of moles of B in the step 2, then we can move on to step 3 to find the volume of hydrogen gas. Another formula is needed, and this is the formula that we need to choose because we have the number of moles of hydrogen gas from step 2, and then we know the molar volume because given in the question under room condition. So the molar volume under room condition is 24 dm³ per mole. So the molar volume 24 dm³ per mole multiplied by number of moles of hydrogen gas 1 times 10 to the power of negative 2 mole. Then we can get the volume of hydrogen gas as 0.24 dm³.